In this video, we are going to practice naming some alkenes. So let's start with our first example, CH3, CH2, C double bonded to CH2, and then CH2, CH3. So this example can look a little bit confusing, so I'm going to expand it out. We have a CH2 on one side, and then we have a double bond to a carbon. One side of the carbon is going to have an ethyl, and the other side is also going to have an ethyl. So that's what it would look like. Now, in terms of naming it, the first thing you want to do is find the longest chain that includes the double bond. So it would be this one for here. You could also do the other one, but we're going to choose the top ethyl. So we have 4 carbons in the main chain, so that would be butene. Now, the bond is in between carbons 1 and 2, and we want to go with the lower number. So we're going to call it 1-butene. And then in terms of substituents, we have this substituent right here, which is an ethyl, and it's on carbon number 2. So it's going to be 2-ethyl 1-butene. Now let's look at our next example. We have carbon double bonded, and then we have an ethyl. How would you name this one? So to find the longest chain, it's going to be this right here. We have 6 carbons in total, which is equivalent to hexene. And the bond, the double bond, is in between carbons 3 and 4. But we're going to go with the lower number, so it's going to be 3-hexene. And in this case, we do not have any substituents. However, this is a cis molecule because the hydrogens are on the same side and the ethyls are also on the same side. So this is going to be cis 3-hexene. How would you name this one? So we have a alkene with 1, 2, 3, 4, 5 carbons, so that's going to be pentene. The bond is in between carbons 1 and 2, but we're going to go with the lower one, so 1-pentene. And then on carbon number 5, we have a fluorine, so it's going to be 5-fluoro. Now the reason why we started counting from left to right as opposed to right to left is because we want the double bond on the alkene to have the lowest number. So the double bond of the alkene takes priority over the alkyl halide or the halogen, which is the fluorine. How do you name this one? Our longest chain is right here, and it is a pentene since we have 5 carbons. Now, do we start counting this direction or that direction? If we count the second way, we have our double bond between 2 and 3. If we count this way, we have our double bond between 3 and 4. So we want it to be on 2, 3 as opposed to 3, 4, because 2, 3 is smaller numbers. So we're going to take the lower number, and that's the number for the double bond. So 2-pentene. And we don't really have any substituents, because if this is the main chain, the only other thing is this hydrogen, which is not really a substituent when you write names. Now, is this a cis isomer or is this a trans isomer? So this is going to be a trans isomer because the hydrogens, which are the same things, are on opposite sides of one another. So one is on the bottom right here, one is on top. So this is going to be trans 2-pentene. How about this example? How do we name this one? In this case, we have 2 carbons, so that's going to be ethene. Now, do we need to put a number before ethene, or like 1 or 2? In this case, we don't really need to, or in any case when you have ethene, because ethene has 2 carbons, and the double bond can only exist between the 2 carbons. So, but in this case, we have 2 chlorines as the substituents. Now, 1 chlorine is on carbon 1, the other one's on carbon 2. You can count it the other way as well, and it would still end up being the same thing. So, in order to name it, we are going to do this. We're going to say 1, 2, because that's the positions on which we have the chlorines, and then we're going to put dichloroethane, or ethene. Now, in this situation, do we have a cis isomer or do we have a trans isomer? In this case, we have a cis isomer because the hydrogens are on the same sides and the chlorines are on the same side as well. Chlorines are on top and the hydrogens are on bottom. So this is going to be a cis 1,2-dichloroethene. Now, let's take a different situation similar to this one. Let's say we have the same molecule, but let's say that one of them is a bromine as opposed to being a chlorine. How would this change the way in which we do this problem, or how we name the alkene? So we still have ethene because we have 2 carbons. Do we want to count right to left or left to right? In this case, whether we count right to left or left to right, the substituents are still going to have 1, 2, and 1, 2. However, if we count left to right, we give the lower number to the substituent with the first letter in the alphabet, because B comes before C in the alphabet. So when possible, we want the B to have the lower number. So we're going to give this carbon, which is attached to the B, the bromine, the lower number. So we're going to go 1, 2 like that. And so we're going to have 1 bromo, 2 chloro, and then we have a cis isomer still because the hydrogens are on opposite sides. How do we name this particular alkene? In this case, we have 2 hydrogens on the left carbon, and then we have 2 ethyls on the right carbon. To count the longest chain, we can just do this chain right here, and that has 4 carbons, so that's butene. And then we have, if we start counting left to right to give the bond the lowest number, it would be this order, and the double bond is in between the carbons 1 and 2. We're going to take the lower one, so carbon 1, and then on carbon 2 we have an ethyl substituent, so 2-ethyl -1 butene. Now let's first expand out this situation to make it easier to understand. So we have the double bond, right? And at the double bond, it attaches to, on the right side, it attaches to a hydrogen, and then attaches to a CH, which attaches to 2 methyl groups. So that's the situation there. On the left side, attaches to the carbon on the left, attaches to 1 hydrogen again, and then attaches to a methyl. Now I've drawn it as cis, so the hydrogens are on the same side, but the structure doesn't actually imply that at all. It's just a CH on the sides of the double bond, so we're not going to call it cis or trans, we're just going to name it without that. So the longest chain would start here, and then it would go, you could either pick this carbon or that one. I'm going to pick the second one. In the main chain, or the longest chain, we have 5 carbons, which would be associated with pentene. And then we have the double bond in between carbons 2 and 3. And the reason we count this way is because we want the double bond to have the lowest number. So it's going to be 2 pentene, because 2 is the lower number here, in between 2 and 3. And then we have, in terms of substituents, we have a methyl on carbon number 4. So this would be 4 methyl 2 pentene. So now let's look at our last example. We're going to have carbon, and we're going to have chlorines. In this case, once again, we have 2 carbons, which would be associated with ethene, and we don't need numbers with ethene because the double bond is always going to be between the 2 carbons in ethene. We have 2 chlorines as substituents, and they're both on the same carbon. In this case, we do need to put numbers for it. We are going to number the carbon on the left number 1 because that's the one in which it has chlorines. So that means that both chlorines are on carbon 1. And we do need to write that because if we don't, then it's not clear if one chlorine is on the left and then one is on the right. So the name of this would be 1,1-dichloroethene.